Okay, this is a quick review for your test. We'll have a little bit of time to look over this on Monday again, but remember with exponential models, we are multiplying by the same thing every time. So maybe in this list, we are doubling. We'll put X up here. We'll do X, Y. We'll do a table. My Y-intercept here is, oops, I did one too many times there. My Y-intercept here is 1 because that's the only one with 0. And so here, and I am doubling, that means in my form AB to the X, 1 times 2 to the X. And yes, I will probably simplify that, just write it as 2 to the X. I do not need to write times 1. Versus this table is going to be a linear equation where I'm adding 2 each time. Adding 2 each time is going to be like my slope. Okay, once I have these equations, I can compare values. Now, if I want to know the value of, say, 20, I can do 2 to the 20th. Or here, 2 to the 20 plus 1, 2 times 20 plus 1. 2 times 20 plus 1 is 41. 2 to the 20th is going to be really big. Hold on, let me use a calculator here. That's 1. I think it's million for, yes, that's 1,048,576. So clearly 2 to the 20th is bigger. Exponentials get bigger. They don't always get bigger quite as quickly. Notice that 1, it was bigger in my linear, and 2 was bigger in my linear. Depending on the equation and the growth rate, linears can get bigger, be bigger for a little bit longer than this, but exponentials will, as a general rule, overpower them. Okay. We also learned about simple interest and compound interest. So if I deposit 20,000 with an interest rate of 4%, for the purpose of my formula, R is going to equal 0.04, okay? R must be my rate converted to a decimal. Make that a little nice. So that means I move the decimal point 2 places to the left, always 2 places with a percent. Okay, so simple interest means I just take my 20,000 and I multiply that by 0.04. And that's $800. That means I get $800 each year. My amount is then 800 times the number of years T plus my 20,000. So if I've got 5 years, I do 800 times 5. That's $4,000 plus 20,000. That's 24,000. Say A of 5. My compound interest formula was an exponential function. my initial amount, 1 plus r to the power of t. So that's 1 plus 0.04 to the t. Remember, with compound interest, I get interest on all my interest. So usually before I put it into the calculator, I just add those two together. So now when I do C of 5, again, I plug in 5 for my t. And now I just use the calculator. It is wise to make sure you have a scientific calculator, because for this test, you're going to need one. It's also important that if you don't, you multiply it, you do 1.04 to the 5th. I don't know how you'll do that without a calculator at all, but, and then multiply by this 20,000. The order of operations, if you have most scientific calculators do order of operations. If you're not sure if yours does, plug this in and check that you get the same result that I do. So with compound interest, we made an extra $333.06. That will get greater as time goes on. Okay, so we have, really important to know this equation. Make sure you put this in your notes. Make sure you know how to convert rate, and that you know that simple interest is the amount of interest times years plus the starting amount. Okay.